Today we are going to study about cyclotron. Cyclotron. It is a device used to accelerate charged particle. Cyclotron is a device used to accelerate charged particle. So we can study the structure of cyclotron. This is the structure of cyclotron. It consists of two D-shaped metallic discs. The cyclotron consists of two D-shaped metallic discs D1 and D2. A magnetic field is applied normal to the plane of the disk, and we have a magnetic field which is applied normal to the plane of the disk. The positive charge particle which is to be accelerated is placed in between the disk. So this is the positive charge particle, and we are going to accelerate this particle using this 2D-shaped metallic disk. Okay, so the next point is an AC source or oscillator of suitable frequency is connected across the disk. When the oscillator is switched on, the D1 become positive and D2 become negative. So this is the 2D-shaped metallic disk, and we have an oscillator connected to it, or an AC source which is connected to the D-shaped disk. So when the oscillator is turned on, initially the D1 will be positive and D2 will be negative. So D1 is positive and D2 is negative, and this is a positive charge. The positive charge will attract towards the D2. The positive charge will be attracted towards D2, and it moves perpendicular to the magnetic field. That is, the magnetic field is into the plane of the paper, and the charge particle is moving perpendicular to the magnetic field. So we know that when a charged particle moves perpendicular to the magnetic field, it experiences a force called magnetic Lorentz force. F is equal to qvb. The charged particle will experience a force F is equal to qvb, and due to this force, the particle will trace a circular path in B. Okay, so that's it. We can read the next point. The particle is attracted towards D2. The particle moves perpendicular to the field and hence traces a semicircular path in D2, and it reaches the gap. That is, when the oscillator is turned on, D1 is positive, D2 is negative, and the charge particle, positive charge particle is attracted towards D2, and it is moving perpendicular to the magnetic field. Hence, it traces a semicircular path in D2, and it reaches the gap. Okay, it reaches the gap. Immediately when the charge reaches the gap, the polarity of the oscillator is reversed. That is, at that time, the polarity of AC source is reversed. Now D1 become negative and D2 become positive as the particle is attracted towards D1, and it traces a semicircular path in D1 with a greater radius and reaches the gap again. That is, the particle traces a semicircular path in D2 and it reaches the gap here. At the same time, the polarity of AC source is reversed. So now D1 become negative and D2 become positive. So the charged particle is attracted towards D1, and the charged particle is now moving perpendicular to the magnetic field. Hence it experiences a force, and due to that force, the particle traces a semicircular path in D1. But but remember the point that the radius of the semicircular path will be greater than that in D2. So initially the radius of charged particle or the semicircular path in D2 is smaller. Now when it reaches D1, the radius increases and it again reaches the gap. At that time, the polarity again changes, and now the D2 become negative and D1 become positive. The same process happens again, but the radius of semicircular track or the radius of semicircular path will increase again. So this process continues, and in each stage the radius increases. So this process continues, and in each stages the radius of the semicircular path increases. So we know that radius r is equal to mv divided by qb and we can write V is equal to QBR divided by M. So from this we can say that velocity is proportional to radius, that is, or radius proportional to velocity, that is, as radius increases, velocity also increases. So we know that the radius of semicircular path is increasing in every stage, therefore the velocity of the particle will also increase. So we can say that the particle will keep on increasing its radius and velocity, and it will be ejected with maximum velocity. The particle will be ejected from the D with a maximum velocity. The radius keep on increasing. The radius keep on increasing. The radius keep on increasing in every stage, and the particle, and finally the particle is ejected from the disk, ejected from the disk with maximum velocity or maximum speed. That is, the radius keep on increasing in every stage, and finally the particle is ejected from the disk with maximum velocity. So we can write the maximum velocity as, we have V is equal to QBR divided by M. Vmax is equal to QBR max divided by M, and where R max is the radius of disk. R max is the radius of disk here. So the maximum velocity of the ejected particle, or the particle is ejected with a maximum velocity of QBR max divided by M, and the kinetic energy maximum will be, the kinetic energy maximum will be half m v max square, that is equal to half m q square b square r max square divided by m square, so which is equal to q square b square r max square divided by 2m. So this is the kinetic energy, or the maximum kinetic energy of the ejected charged particle. So the next point or note: for the proper functioning of cyclotron, for the proper functioning of cyclotron, the time period of AC source, the time period of AC source and charged particle should be equal. The time period of AC source and charged particle should be equal. Should be equal. That is, time period of AC source is equal to time period of particle. We know that time period of particle is 2 pi m divided by qb. Therefore, according to this thing, for the proper functioning of cyclotron, the time period of AC source should be equal to 2 pi m divided by qb, or the frequency of AC source should be equal to qb divided by 2 pi m, and this frequency is called cyclotron frequency. This frequency is called cyclotron frequency. Next is limitations of cyclotron. Limitations of cyclotron. The main limitation or the main disadvantage of cyclotron is only only charged particle can be accelerated. Only charged particles can be accelerated. Only charged particles can be accelerated. The second limitation is electron cannot be accelerated. Electrons cannot be accelerated. Electrons cannot be accelerated because its mass is very small. Its mass is very small and it obeys relativistic condition. Electrons cannot be accelerated because its mass is very small and it obey relativistic condition. Relativistic condition. So there are two major limitations of cyclotron. First one is only charged particles can be accelerated. Second one, electrons cannot be accelerated because its mass is very small and it obeys relativistic condition.